I'm logged out. Okay, let me see. Hold on a second. Okay. That's weird. Okay, let's see. Math. Group meeting. Okay, should we do the quiz?
Yep.
Okay.
Is it bad that I already started? I got through 7 so far.
Oh, you're already
You
in
already
there.
I'm saying, I'm like, let me take a look at it, see what happened, how bad it is. It's pretty easy.
Oh, yeah.
Not bad.
Okay.
Okay. Which hypothesis involves equality? The p-value is the probability of obtaining a sample statistic, at least as extreme as the one that was actually observed.
So remember that the p-value is the probability of obtaining a sample statistic, at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? It's the null hypothesis, right?
That's what I think too. Except, is it? Okay. That makes sense to me.
Well, because you're always assuming the null hypothesis is true. It's the alternate one. Well, I guess you're trying to prove, well, I mean, you assume it's true until it's proven otherwise.
No,
Yeah,
you're
but they're
right.
talking about the p-value. So
Here's the definition straight from the text. The p-value is the probability of obtaining a test statistic, at least as extreme as the one you calculated, assuming the null hypothesis is true.
Yeah.
So.
okay. Good. Okay, which of the following represents the alternative hypothesis for a two-tailed test? It's the not equal.
Yep. Equal 10.
Yeah.
The alternative, or the mean, does not equal 10. Is that the one you're saying?
Yes.
Yeah, the not equals, the equals with a slash in it, yeah.
Yeah.
Left-tailed is pointing to the left. And right-tailed is pointing to the right.
I see why now why you said this is easy so far.
Okay.
But there are 21 questions. Oh,
Yeah.
getting long.
I'm worried for what's coming later.
Exactly.
Remember, you determine the outcome of a hypothesis test by comparing the p-value to the level of significance for, what is that? Alpha?
Yeah.
Use this information to answer. Which relationship would result in failing to reject the null hypothesis? Huh. I do not know.
Anyway, hold on.
Oh, a large p-value. So greater than or less than, oh.
So yeah, if the p-value is less than alpha, we reject the null hypothesis.
Okay.
If p-value is greater than alpha, we fail to reject the null hypothesis.
So if the p-value is greater than the alpha, the relationship that would be resulted in failing to reject the null
Then
hypothesis.
we don't reject it, yeah.
Okay, so
Wait,
the
hold
first
on,
one.
I'm confused. It's the first one?
If it's greater than
Which
alpha,
relationship?
we don't reject the null hypothesis.
If p is low, reject the null. So we don't reject when p is high. So p is greater than, yeah, so the first one. Okay, I got that.
And then it's just the reverse to
P
reject
is
it.
low. So that's going to be the second one on number 9, right?
Yeah.
Okay. Good. That makes sense.
Good.
Okay.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be the appropriate alternative hypothesis?
The average, alternative is higher, so the average claim is greater. I think it's the third one. They're thinking that it's going to be higher. Yep. Okay.
Yeah, so the average amount is greater than 1,500.
Right. Which of the following would be appropriate null hypothesis? The average claim is equal to 1,500.
Yeah.
Yep. Okay, good. So far, so good. Okay.
I like it.
I know this one. The insurance company randomly selects n equals 40 claims and calculates a sample mean of 1,650. Use this information. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
So yeah, because it's larger than 30, the sample size.
Yeah, that's what I think. It's a good assumption. Yes, sample size is large. That's what I think.
Okay.
What theorem or law justifies, oh gosh. Let's see.
Well, it's the central limit theorem, right?
Yeah.
Okay.
I just looked
Not
at
the
it.
law.
You're good. Yeah.
Which of the following is the test statistic as defined in this list? Is that Z?
I think it's the first one, X bar. Wait, that's the mean.
Yeah.
The test statistic, maybe it's N. Okay,
So
let's
N
see.
is the sample size.
Z is a
It's
test
Z.
statistic.
Oh, yeah, it's Z.
Yeah.
I knew it.
In the book, it says give the test statistic and its value, and then Z
Yeah.
equals. So it's
Yeah.
the,
I just did that too.
okay.
No, we're good.
The historical mean of sales receipts at a grocery store is 150 with a standard deviation of 40. Store manager suspects that the average has decreased. She sets up a hypothesis with the test hypotheses. Null is the mean is equal to 150. And the other one is greater than 150. What is it? Oh, alternative. right?
Or the mean
Alternate?
is less than 150, right?
What?
I said the alternate hypothesis is less than 150, isn't it?
Oh,
Yeah.
yeah, less.
Yeah,
You're
I
right.
think they spend less.
So should we use a little difference?
0.5 in a simple random sample of 36 sales equals 144. Oh gosh, okay.
Okay. So
Do we have to? We don't have to make the. Okay,
we don't have
so
to make what?
in the book, and it said make a histogram. We don't have to make a histogram just to compute this.
No.
Okay, let me just plug these in. The mean is where am I looking?
144.
Oh,
Because are we supposed to use the formula Z equals the sample
yeah, that one.
mean over standard deviation divided by the square root of the
Yeah.
sample size, but there's no size.
standard
Or maybe
deviation
it's not how that one's got it. But
40.
then what's the N?
N is
How many people? The
Oh,
36.
it's 36. 36. I
Yeah, it's
didn't
36.
36. Yeah.
Yeah. Okay.
B, so it's 40. Okay, wait. X minus the mean. What? Oh, 144 minus 150
Yeah.
is negative 6.
Divide that by.
The standard deviation over the square root.
Yeah, of 36. That's what we get.
C5, that one's 36. Got it. So is it negative 0.9?
I
didn't
have 0.8999. We have to round to the 3 decimal places. Derek, what do you have?
Same as you, actually. But yeah.
Okay, I didn't have my decimal places out, so I better do that. Hold on.
899, right?
Yeah.
I still have 0.9.
You can't like round up and do 3 decimal places though, so I don't know. But 9, you're supposed to round up.
What did you guys get?
I'll just put
0.899?
0.899 for now and submit it and see if it's right.
Yeah.
You have to round the next 9 up.
Yeah, we'll see.
I know, but it says round to 3 decimal places, so I get nervous like putting just 0.9.
Yeah, no worries. We'll just leave this for now, and Rosalie, we'll just go back and see if it's right.
Okay, because mine,
No worries.
I can't even get 3 decimal places. Mine came out on Excel to 0.9, and that's it.
Oh, you're doing it on.
Weird.
It's okay.
Well, you might have to
No worries.
go into your and change that. But so
Okay.
what is the p-value associated with the z-score from the previous question? P-value is the probability, so we have to go in the applet, right?
Yeah.
Yeah.
So let's plug it in. And just make sure we have that.
Come here, you. Here we go.
Oh, there it is. Did have it.
I always get confused on where I'm supposed to shade sometimes.
Negative 0.9. Okay. Yeah, I do too. But I think it's to the left of what we're putting in. So it's, is that right? So it'll be
That's what I'm thinking.
0.184.
Yeah.
Oh my gosh, I have to find my test again.
Okay, what inference would you make about the null hypothesis for this problem?
0.184. Okay.
Uh,
About the null hypothesis. So P is, remember, if P is low, then reject. And it's 0.1.
Or-
So I say it's reject. Because 0.1. Oh, does it have to be less than a certain, less than 0.05 for the level of significance?
so
But
it's
it's
above.
not less. See, in the before question 15, it says she's using a level of significance of
Yeah.
alpha. So it's not less than that, it's more than that. So I think it's failed to reject.
Gosh,
I don't know.
sometimes.
What do you, what?
I said it's like so, it sounds so easy when you read it, but then when you have to work it out, you're kind of
Like,
second
wait,
guessing.
True. Yeah, I'm not sure on that. But we'll know the second time around because there's only two choices. But look, on the,
oh wait, hold on.
it's weird.
Oh, wait, so if p-value is less than alpha, we reject the null hypothesis.
But
If
it's
the
not
p-value is
less.
greater than alpha, we fail to reject the null hypothesis. There we go.
Okay.
That's right.
Good.
Okay, yeah.
Hmm.
Okay, what is your conclusion for this problem? We have insufficient evidence that the true population mean is 150. We have sufficient evidence that the true population mean is 150. We have insufficient evidence that the true population mean is less than 150. Or we have sufficient evidence that the true population mean is less than 150.
Oh my gosh. Wow. Okay, so originally she thought it would be less than 150, and we failed to reject, which means that one can stand that it's equal to 150, not
There's less than. It's less than, right? Because that's what we're saying. Is that what she predicted was true?
Well,
But we failed to
okay.
reject the null hypothesis, so that means the mean score was 150, or the mean of the sales receipt, right? So by failing to reject the whole null hypothesis, we're saying that the mean is 150. And that she was wrong.
Or are we saying that it's not less than 150?
No, actually, right. The null hypothesis is equal to the 150.
So it's the second one?
Yeah, I think so.
I mean, that's what I think.
Yeah,
But
that makes sense.
I think it's the
that's what makes
opposite.
sense to me.
I mean, I think it's that one, but in a different wording. Just because they said we never accept the null hypothesis is true, we just don't reject it. So I think it's we have insufficient evidence that the true population mean is less than 150.
Yeah, I think you're right on that one. Yeah. Because that's what you were trying to prove, is that it was less. So
Right.
we don't have.
And then you can't. Yeah. And so they were saying it can't be proven ever, but you can say that you can't disprove it.
Yeah.
So confusing. Okay.
I know. You really have to think about these things. Okay,
Yeah.
there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? That's type 1.
Type 1.
Yes, it's 1. Okay.
All right.
And a researcher decided that instead of using a level of significance of 0.05, he will use 0.01. Which of the following will be true?
Okay. So I know it's one of them will increase. And is it a type 1 or a type 2? Because
The level of significance is standard for determining, okay.
I think
Typical
it's
values.
the probability of a type 2 error will increase.
So if a type 1 is, oh, okay, I get what it's saying.
Okay, wait, you think it's which?
I think it's
Type
that
2.
a type 2 error will increase.
Yeah.
Type 2?
Yeah, type 2
Yeah.
error will increase.
Oh, because it's false, but we failed to reject it.
Well, it's because when you have the alpha so low, it decreases the probability that you'll have a type 1 error, but it also increases the probability that you'll have a type 2 error.
Okay, good.
So the last one, if alpha is 0.05, compute the probability of committing a type 1 error.
What?
No.
How are we supposed to do that?
I think that's from our preparation assignment. And look.
Okay, that was just me flipping out. That's all.
Okay.
Type 1 error. I don't remember reading that one.
I don't either.
Great.
I know, of course, the last one's like
I think it's
something.
50-50. Right?
What?
So it's like, okay, so a level of significance of alpha equals 0.05 seems to strike a good balance between the probabilities of committing a type 1 versus a type 2 error. I guess. I don't know.
Oh, gosh. So, Oh. This is really confusing.
Oh,
One of
so the value of alpha is the probability of committing a type 1 error. So 0.05, right?
if alpha is allowed to be very large, then the probability will be very small. So it's opposite. I think it's
So I scrolled all the way down to the bottom where it goes to summary on the reading. It says the value of alpha is the probability of committing a type 1 error.
right.
Oh. So then it's 0.05.
That's what I thought.
I'm just going to try it.
Yeah, I see it too now. It's in the reading. 0.05.
Okay, I'm going to
Yeah.
submit and we'll see.
Okay.
I knew I saw it somewhere.
Yes, good one.
Okay, so we missed 3 questions. The last one was right.
Okay. Which ones did we
Okay.
miss?
We missed 15. What is the z-score associated?
So it might be the point.
Oh, well, mine might be then 0.9.
Yeah, let's go with that one.
I haven't submitted mine yet, but I'll change the other 2 and then submit before you guys do yours.
Okay. What was the other 2 actually?
Well, I missed 6 and 7. And maybe I just needed to, maybe I just did those wrong myself.
6.
Is 6 the first one?
Alternative hypothesis for a left-tailed test.
I switched them. I didn't mean to, and I switched them. So you guys probably got that.
So did you do the first one for 6?
Yeah,
You did the first one for 6?
I did the first one.
Like A?
Yeah. So it's supposed to be the first one. Okay, so now I just need to write these down. So
7 was the second one.
7 is the second one, yeah.
Okay. 1 double 10.
Okay, I'm going to submit mine.
Okay.
Okay. I got 15 right. Negative 0.9.
Cool. Did you get 100% then?
I wish they wouldn't have said put it to the nearest or like the 3rd decimal point, because I would have gotten it right.
Yeah.
Cool. Here we go.
Okay, wait, don't click out of anything when you're done because I might need.
Okay, I still have it.
I'm writing down my answers right now.
Good.
Wait, what was 18? I got that one wrong apparently.
Oh, 1, 2, 3, the third one down.
My bad.
It said we have insufficient evidence that the true population mean is less than 150.
Okay, let me open up another. Here we go.
Okay, so 15 is negative 0.9.
Right.
No. Two-tailed test, that's it. Eight was the p-value is smaller than the A, right?
Which one?
No, greater. I don't know. Remember.
I don't know what number you're on.
8. I always forget, like these like trip me up. I don't know what's going on.
Yeah, it's the first one. P-values greater than.
And then the set 9 is the second one.
Yeah, and the second one is the. Oh, 9 is the second one. Yes.
And then 10 is average claim is greater than. Yeah.
Yeah.
Equal to.
Yep.
It's a good assumption.
Yep.
Central limit.
Yep.
15. Negative 0.9. Here we go. 16 was
0.184.
That's right. And then we are failing to reject.
Yep.
Which one was it? Insufficient value.
Yeah, third one.
Type 1.
Yep.
Type 2 increase. 0.05.
Yes.
Awesome.
Awesome.
Awesome sauce.
I
like it.
Yep. Goody. All right. Cool. We good?
Yeah, I think so. I think we're.
I haven't submitted mine yet. Sorry, guys.
Oh, that's all right.
Sorry. Just cruising through.
Yeah. I'll stay on. Got to make sure.
Yeah, exactly.
Okay. All right, hopefully I put them all in, right?
Yeah.
Okay, we're good.
Cool.
All right, I'll post this for everyone.
So
Okay, Monday,
next
same time?
week. What's that?
Yeah, let's do Monday, same
Monday.
time.
Deal. Does Wednesday or Thursday work better for people?
Wednesday works good. It still works great for me, but we could change it to Thursday if you need.
Okay. Well,
Monday,
we'll talk about.
I'm not good for Monday. I have a thing at 7.
Okay.
So we can do earlier or we can do later.
Later works
Or
best.
we could do Sunday. Is it up on Sunday?
I don't know.
care.
I
Sunday,
could do Monday, or we could do Sunday night.
Sunday, I'm traveling.
Okay.
Okay, so let's do Monday night. What time Monday night works for you, Rosalie?
Whenever.
Well, my
We can do it.
7. I could probably be back by 8:30. Or we can do it before.
We can do it at 9 if you want to. It's not a big deal. I don't mind.
Okay, so let's plan on 9. Pacific time and 10 Derek's time then. Is that okay, Derek?
Yeah, that works.
Okay.
I
Okay,
guess
good.
you need them to prepare. That's fine. Whatever works, you know.
Right.
Okay, great. So
9.
let's plan
Okay. If I'm back early, I'll just turn on my computer and see if you guys are on, but I'll be on for sure by 9.
Okay, sounds great.
Thanks, guys.
Yep, thank you. Bye.